When not to use a data management system or DBMS. Here are critical scenarios every developer should know. A database management system or DBMS is a powerful tool. It helps to manage and organize large amounts of structured data, but it is not always the best fit for every software application. It is an intricate system that can be expensive to design and maintain. It carries overhead costs in its initial investment in hardware, software, and training. The costs in security, concurrency control, recovery, and integrity functions. Many developers may choose a solution based on the hottest and latest tools, not on what is best for their software applications. I encounter the same question often from developers, where they question my reason for not choosing X or Y system for my applications. It is usually the trendiest database tool in the market. My answer is often the same. I use what is the right tool for the job. It is imperative to understand the needs of an application to choose a database solution. Let's explore more scenarios where a DBMS might not be the optimal choice for an application. Simple data structures. You do not need a DBMS if your application deals with simple, flat data structures, where there is no need to create complex relationships or querying capabilities. A simpler data storage solution like a key value store or a file-based system may be enough. These can be flat data structures, with key value pairs that represent different settings. Examples of applications that use simple data structures are as follows. A basic blogging platform may use flat file systems to store blog posts, where it saves each blog post as a separate text file that contains a title, content, and metadata. The early versions of Blogger used flat file systems to store blog posts. Static website generators like Hugo and Jekyll process static Markdown or HTML files. Mobile games use flat data structures to store game state, player progress, and scores. Note-taking apps like Google Keep or Apple Notes store notes as individual objects with properties like title, content, and creation date. These may use flat files or a simple database to store notes as the underlying data structure is flat. Real-time, high-throughput data processing. These can be applications that process massive amounts of data in real time. For example, financial trading systems or social media platforms, where there is a need to store large amounts of data and respond to queries in milliseconds. A NoSQL database or stream processing systems like Apache Kafka or Apache Flink may be best. Embedded systems and IoT devices. Resource-constrained devices may not have enough physical resources to support a DBMS. Common devices like smart appliances or wearables are perfect examples. They might only need to store user and configuration settings for a single user. A lightweight data storage solution like SQLite or LevelDB may be more appropriate. Temporary data storage. A DBMS may not be optimal for applications that update or delete data often. For example, session data in a web application or temporary results of a data analysis job. These can store data in a temporary file system. A DBMS might not be the most efficient choice. A temporary file system or an in-memory database can be more suitable for such use cases. A DBMS may have its place in software development projects. If developers lead with well-defined project specifications, they may have a good chance to pick the right tool for the job. A DBMS may work when the specifications call for complex relationships among data, with integrity constraints, rules, triggers, among others. The same applies for projects that don't need a DBMS. It is never a good idea to choose a database solution based on the latest trend. Understand the needs of the application and choose the tool based on them and nothing else. This increases the chance to pick the right tool for the job.